Good morning. My name is Melvin Escudero. I am the chair of the Council for Advocacy in the Pacific Alliance, in Latin America and the Caribbean. 13 societies in our region. So we are very proud to present this webinar about data science and artificial intelligence. This is an issue and a topic that everybody wants to know where is going on, what is going on right now in the markets, who are the big players, and especially what will be the value that this new technology will bring to the asset management business and in general to the investment world. We are proud to present this for the first time in our region. And of course, we will rely on a couple of big experts on this issue to give us inside data and information that bring us valuable tools to do next steps. For doing the interview and moderate this panel is with us Inigo Bengoechea. Inigo is from CFA Institute. He is now in New York and he is responsible for advocacy for our region. Go ahead, Inigo. Thank you for being with us.
Thank you, Melvin, and good morning to everybody. It gives me great pleasure to welcome you to our inaugural webinar on AI and data science. As Melvin mentioned, our 13 Latin American and Caribbean societies collaborated to bring you this webinar, and I'd like to take this opportunity to express my gratitude to our volunteers for their efforts in making this happen. We have a very exciting program for you today with two fantastic speakers who will help shine light on these two very important industry themes. And it's no secret that artificial intelligence and data science are empowering businesses to provide new products and services in the age of digital transformation. These capabilities, rather than relying on human intuition or instincts, offer firms and investors with massive amounts of data to help them make better investment decisions. Turns out that calling investments based on your gut feeling, as the old adage goes, may become an approach of the past as data increasingly drives investment decisions. New reports come out every day predicting that AI and data science will lead the majority of investment decisions by mid-decade. Successful investors are said to have a good gut feel, the ability to make sound financial decisions from mostly qualitative information alongside quantitative data they are provided here and there. However, this impossible to measure or quantify inner voice or gut feeling grown from personal experience is decreasingly playing a role in investment decision making today. And it is the combination of data science and AI that is helping drive this revolution. Data science with the pre-processing, analyzing, visualization, and prediction of data. And on the other hand, AI as the implementation of predictive model to forecast future events. This combination is proving to be a powerful force. And so this approach is being used to build sophisticated models that can better determine the viability, strategy, and potential outcome of an investment in a short amount of time. Questions such as when to invest, where to invest, and how much to invest are becoming almost automated. And today, here to provide us with the necessary understanding and give us some proof of this methodology, of this approach, is Larry Chow and David Wang. Larry is a Senior Director of Industry Research at CFA Institute. He conducts original research with a focus on the investment industry trends and investment expertise. His current research includes multi-asset strategies and fintech. He has more than 20 years of experience in the investment management industry. Prior to joining CFA Institute, Larry worked at HSBC as Senior Manager for the Asia-Pacific region, and he started his career at the People's Bank of China as a US dollar fixed income portfolio manager. He also worked for US asset managers, Munger Capital Management, managing US and international equity portfolios, and Morningstar Associates, managing multi-asset investment programs for a global financial institution clientele. Welcome, Larry. Alongside Larry, we are also delighted to have today with us David Wang, who is a managing director at State Street Bank. Currently at State Street, he's responsible for artificial intelligence and financial modeling. David has more than 20 years of experience in the investment management industry. with responsibilities in portfolio management, trading, modeling, analytics, risk, financial technologies, and acquisitions. Prior to joining State Street, David was managing director and project manager at Coppola Capital, Fidelity Investments, and Western Asset Management. He received his PhD in computing engineering from University of Massachusetts. He holds an MBA in entrepreneurship from Babson College and earned his bachelor's degree in electronic engineering from the University of Science and Technology in China. Welcome, David. So Larry's gonna start us off with his presentation, and David will follow and speak to some of the practical cases from State Street. At the end of their presentation, we'll have time for questions. You may also submit your questions as they present. They will consider answering them as well. So I encourage you to send them through the chat. And thank you all, and the floor is yours, Larry.
Great, thank you, Inigo. And thank you very much for the society for organizing the event. So we have an opportunity to share our research with you. So let me put up the slides. As Inigo said, my name is Larry Cao. I'm an industry research director at CFA Institute. So, today we'll go through with you some of the important topics in this AI and big data application in investments. Right? So we'll talk about three things mostly. One is really defining the issue. What is AI and big data application in investment? What are we talking about, right? What can they do? And two, is how should we respond, right? As investment professionals or as data scientists working in the investment business, what are the benefits of AI? What is the status of adoption in the industry? How the industry is responding to it? And what are some of the hurdles? And how do we overcome these hurdles, right? So that's kind of the focus of this presentation. And then lastly, I'll touch on some of the concrete cases. I'll touch on a few cases from different angles, but also referring you to our other research where you see a lot more details on these. And David, again, will also join later to give you concrete cases on the on AI and big data applications as well. So with that, let's get into it. So a lot of my presentation is based on the three reports we've published over the last few years. The main focus of this presentation, most of the content comes from the one in the middle, AI pioneers in investment management. And a lot of the concepts that we did mention and touch on them in Investment Professional of the Future, which was published slightly earlier. And then some of the next steps was actually elaborated in more details in this T-shaped teams report. So I just want to highlight these in case that you're interested. So first one, defining the issue, right? So AI became a household topic, very much around when AlphaGo started beating the best human player. So this was about 6-7 years ago. So people are naturally wondering if this AI is beating human in the most sophisticated game, how long will it take for AI to take over the investment business as well? So you see the interest started to pick up, and then it hit a peak, according to Google, around sort of in 2018, early 2018. And that's fortunately for us when we pushed out our first series of content or reports on AI and big data application in investments. Obviously it was very popular. It was very, very nicely timed. The hype or the talk about using AI and big data has come down since. So to us, that's actually a good thing. If you think about the Gartner adoption curve, that's actually really what happens. There's a lot of hype, but then not everybody will get into action. But only for those who get into action, you'll see continued interest. So even though the interest appears to be coming down, but it's those who are really interested who are actually doing things that are following through. So it's more real in a lot of ways. So to sort of at a very high level, to summarize this, AI and big data really enable human beings to do two things. One is to process new data. The other is to process data in new ways. And I'll explain what that means. So this is what we call AI today, basically. I think there's a lot of different talk about AI, and this concept moves around from time to time. But the more sort of a series of areas and branches in AI are sort of, this is the cognitive areas. It is NLP, computer vision, and voice recognition. So NLP is really computer programming. They help us process text information. And computer vision is really the computer program that help us process, these images. And then voice recognition is voices, right? So they kind of process different type of information. Big data, sometimes it's called alternative data, sometimes it's called unstructured data. And alternative simply means it's not mainstream, it's not what everybody uses. Unstructured is more technical, I guess. It means it's not readily processable. So that's kind of what this is all about, right? There's a lot of overlap, but it's not identical. For our purpose, we kind of use them interchangeably because they're mostly kind of overlapped. So the other area that you probably hear a lot, definitions of AI, is machine learning and deep learning. I think without really understanding the computer programming aspect of it, machine learning and deep learning are just branches of artificial intelligence, right? Machine learning that really it helps the AI programs to learn on its own, so you can continue to improve. And deep learning is just one branch of machine learning. They learn by adding more and more layers in that process to understand things, right? So AI is really input to output. Deep learning simply means between input and output, they actually learn on a sort of level of multiple layers, hundreds of layers, if not more. And where are we in terms of the technology, right? So computer vision, NLP, and machine learning, and voice recognition, we've listed some of the major milestones over the last few years. By and large, these technologies have basically enabled the computer to be on par with average human beings in doing a lot of these tasks. In doing these cognitive tasks, right? Understanding images, texts, understanding, I guess you add the, quote unquote, is not sort of understanding, but they can convert them they can answer questions properly based on that information. That's how you define understanding, I guess, in a way. They look at a picture, they recognize what it is, either a cat or a fish, and that's what you think, in terms of understanding. And machine learning, I think to me, that's a very scary part, is they can not only learn other things, they can help themselves to program better. So it started with AutoML, and recently, it came out, I think, a couple of months ago, AlphaCode, right? It really, according to Google, they said it reached a competitive level of performance with human developers. So they're not only taking everybody else's job, they're going to take computer programs jobs as well. So they're fairly, competitive. So this is a summary of what we have discussed so far. So the two things on the left hand is new data and new ways to process data. But then we further, separate the new data into two types. One is the technology, to help people extend their cognitive abilities. And two is the actual data. And then type three, is sort of the new ways to process data. you don't need necessarily new data to generate new output. You can put machine learning and deep learning onto some of the existing data, you can still get new insights. But the most popular applications obviously are using machine learning, deep learning on top of new data. So this is they're not independent of each other. There's just 3 different ways of looking at this. A lot of time they're combined. So a couple of cases before we get into the more concrete cases in the last section. So just to give you a flavor, these are some of the high-profile cases that's been publicized in the media. So one is manager monitoring. If you run application or fund-to-fund programs, and I did that for Morningstar back in the days, and one of the challenges you have would be, what do you do with an underperforming manager? And if the manager is underperforming, when do you drop it? And what would be a good reason to drop it? Because we always tell people to invest for the long term. Can you drop them if they underperform for 3 months? But if you don't drop them 3 months, 6 months, and 9 months, quickly it can become a long term. So how do you make that decision? So GPIF, the largest government pension fund in the world, got together with Sony. So they developed some programs together. And their approach, I think, is fascinating in the sense that they punish managers, they punish underperforming managers for deviating from their mandate. If you're in that business, you'll know deviating from the mandate, meaning if they gave you a mandate to manage large cap growth product and you got into either mid cap or large cap value, then that's not your mandate. You're getting into a different field. If you end up getting into a different field with the money they trusted you to manage in large cap growth and you underperform, then that's a good reason to fire you. But otherwise, if you're within your risk parameters, they will give you more leashes, right? So they'll give you longer leashes to perform. So I think that was a thing that the machine learning allows them to do. The other interesting case, and this is fascinating to some, and a lot of other people will cry foul, is health screening. So John Hancock is one of the largest insurance companies in North America, right? So they obviously do a lot of insurance policies. And if you're familiar with that process, you'll know they ask you a lot of questions, right? So if you don't have to do a physical test, then they will actually charge you more probably. But a lot of times they ask you a lot about habits. Do you smoke? Do you exercise? All sorts of things. But John Hancock found out from their own pool of data, the people from their policyholders, they really just need one thing to distinguish these people, which is this, right? It's this smartwatch. So people who wear these devices, they figured out, actually on average, live a dozen years longer or something than the rest of their population. These are just people in their data sets. So that's a very dramatic difference. Using one additional data point, they can actually segregate these people. And just imagine if you're in the insurance business, right? This means you can delay your payout to people a dozen years later than your competition. That will be give you a tremendous edge. And of course, a lot of people are saying, oh, this is so unfair to those people not having those watches. But it's really not the watches that matters, right? It's everything that leads to your decision of buying that watch probably is helping, not the watch itself, right? But just a case to show that data can add a lot of value in this process, not to value judgment either way. And then another intelligent pricing, again in insurance. This is the Zhong'an. This is actually what Alibaba, Tencent, and Ping An got together to do. And a lot of other firms that do this now around the world, is they give you this box and you can then connect it to your car. And then the insurance company will have access to how you actually drive, where you drive, when do you drive, how fast are you stepping on that brakes, and all that information automatically sent to the satellite from that box. So if you got into an accident, they will know whether you step on the brakes too fast or you you step on gas accidentally. And they can also see, whether where you are, if you are in the wrong place at the wrong time, are you in the high risk area? So they can analyze all this information and then decide what's the right pricing for you. Just imagine all the additional information, the power that it gives them in accurately price your risk. Because for those who did not have that information, if they price their risk lower, they would give you an insurance policy that's too cheap. They would lose money on that. If they price their risk higher, they would not have had you as a client because you would have gone to Zhong'an and got this more accurately priced, the insurance policy. So either way, they will lose out. So this is another fantastic case of showing the power of data. The last one, a very popular case in the media, is Tesla. This is from a few years ago, before Tesla is so obviously a winner in this business. One of the concerns that people had was Tesla going to make enough cars, right? This is before they opened their factory in China, so people have no concerns now. But back in the day, their production was not always up to their projections. So guessing how many cars they'll produce every quarter, really, who had the better guess really actually makes you a better analyst. So how do you get a better guess? You cannot actually sneak into the factory to check them out. That will be against all the ethical rules and all that. So how do you do that legally and sort of with the publicly available data? So some of them figured out one thing. They said they can figure out how many people are working in the Tesla factory. And are they working 2 shifts or 3 shifts? Is the factory running at full capacity in that sense? How do you figure that out? They can figure out how many people are in that vicinity using cell phone data. They can see how many cell phones are actually operating from that Tesla factory. So they can use the publicly available data to triangulate and different points in time, how many people, so they can know how many shifts they're working. And they use that to approximate the production, which is obviously a lot better than just guessing or counting cars, sitting outside of the factory. So this is sort of a new way, a new technology enabling to do things differently now. So some just very high level cases. And I would encourage you to send in your questions, either using Q&A or chat. You don't have to wait all to see the end. We reserve half an hour in the end for discussion, but you are more than welcome to send the question in as you have them. And we can, if it fits with the flow, we'll answer them right away. If it's for a later section, we'll wait till the later section to respond. But it'd be wonderful if you can start sending them in as you get the questions. So with that, I'll get into the second section, right? So this is kind of the key of this presentation. It is to say, what is the benefit? So there are some general benefits. You look at the first 3. All this data is from different surveys we've done at different points. This one was done last year in Asia. And you would imagine they'll gain additional insights, they'll make better decisions. All these are natural, right? So it will allow staff to use time more productively. All these are natural, but harder to quantify. I think at a higher stage of adoption, you see the last 2. You either increase sales or you reduce headcount. So these are the things that hit your balance sheet and your income statements. So it really actually helps you in memorable ways. Eventually, all of your AI activities, I think, will be measured on this basis. How did it help? But in the beginning, I think for people to move their perception, etc., I think the first 3 are easier to gauge people's perception. So I think more people are convinced that this will work, but for the more advanced ones, they start to see concrete results. So this is an earlier survey that we did globally. We did this, well, almost 3 years ago now. So we asked portfolio managers, what do you do with these quantitative tools? And back in those days, there were about 10% of the portfolio manager were using AI and machine learning. And these specific tests we mentioned, on average, again, it's probably 10%, right? These are sort of different applications of AI and machine learning, et cetera. And analysts, we asked the analysts, do you use this more? A bit more, but not a whole lot better, right? Different tasks of using AI and big data. Do you use this? Do you use that? We listed some of the specific categories, and you see not dramatically better. But things I think do change, right? This is from the more recent survey in Asia, and we really grouped them into 3 stages. You're either pre-adoption, meaning you're not doing anything, or you're in the early adoption stage. Early adoption meaning you probably have either developed some individual applications or you purchase something off the shelf. Early meaning you haven't, it's not widespread. You're not using this across departments, across geography or etc. And then intermediate and advanced are basically where you've overcome that. You're really using this a lot more. But things are looking up, right? So by now you look in Asia, you actually see more people in the early stages and more people in the intermediate to advanced stages. So about 60% of the people are using AI consciously somehow, which is wonderful. There's a question, and it's a good time to answer them now. So are we seeing changes in the tools that PMs use over the last 2 or 3 years? I'd love for David to chime in here as well. From my perspective, I don't think so. I think the AI and big data, the core science of AI, hasn't made dramatic, hasn't really progressed dramatically over the last 2 or 3 years. So the tools are basically still the same. And we'll talk about this a bit later as well in terms of our attempts to give you that more concrete answer to each one of these, to have things changed. So let's see. So, why are we not seeing this at people, why not we're seeing everybody getting excited about this? So, we talk about all these benefits, it seems it's a game changer. So why only, about 20% of the people are in the intermediate advanced stage, maybe another 40 in the early stage, and there's 40 that's not doing anything at all. So why aren't we at 100% adoption? Like Excel, everybody uses Excel. So when is AI and big data going to be like Excel for the investment managers? And so this is why. So we use this pyramid to discuss, what are the hurdles? And the one on the bottom are more widespread, but easier to get this resource. As you get higher, meaning as you advance, as you climb this fintech pyramid, you overcome, tougher hurdles, and the resources that you need are tougher to come by as well. So, the more general answer is when you ask people why they're not doing this, a lot of it is cost. This actually is super costly. It costs more than many other type of IT projects even. So people don't want to get into this. And especially in the beginning, a lot of people are wondering where's the benefit, right? It's not obvious to everyone. You do this, you can add 50 basis points to your performance. It's not that direct. So people there's a lot of things you need to process. So to make that kind of investment decision is challenging. The one that people see more sort of direct, in a more direct fashion, often is talent. And we're not talking about schools not churning out enough graduates in AI and data science and computer programming. It's more people, not enough of these people have real world experience. We'll talk a bit more about that later, but the talent shortage is exacerbated because the advanced developments are done at either the tech giants or the industry leaders in different industries. And these people are hard to come by. And from what we've learned, there are not many people, like David, with advanced degrees in data science, in computer programming, that would join the finance, actually, and to work in finance. A lot of the talents got into other industries, right? So finance is only one of the industries, and it's not always the most attractive. Technology, this is another challenge. As technology is evolving, and a lot of that is sort of the like data governance, for example. I think there are lots of challenges, data privacy issues, right? Those are just more of the obvious things that need to be resolved. And also, how do you explain AI to people who don't understand it? So these are some of the technological challenges among many of them. And as you overcome all these, the most difficult one we often see is vision. It is the people at the top of the company need to make that decision. They really need to understand the impact of AI and big data, on the long-term trajectory of the firm's development. So that's sort of the thing that's not always there, because the investment business, we all come from a very different background. We don't necessarily understand what AI and big data is all about. So that's challenging. And even if you can, somehow take care of all these, the one thing that no one has an advantage is time. Because this is so new, no one has done it before, everybody pretty much has to start from scratch. So you cannot save time to put these things actually into practice, right? All that adoption process is probably going to take about the same amount of time for each firm. So if you don't start now, and when your next door neighbor is starting, 2 years later, you're still 2 years behind him. So that's kind of the challenge for this thing. If you don't start soon, then you'll be falling behind. And if your competitor gets to the top of the pyramid before you do, it becomes more challenging for you to scale the pyramid, because they own the space by then, probably. So this is a survey that we asked. We did the pyramid, I think, in the first paper in that investment profession of the future in 2019. And this is a survey from last year. I think it still pretty much bears out our hypothesis. So you see, cost is one of the reasons there. It's lower. Our guess is not our respondents are senior enough to understand the cost implications, because they don't actually have to deal with this cost basis day in, day out. But everybody sees the talent issue, right? The talent is a big deal. In data, this is the technology issue, is a big deal, because these are the things that people work in this business have to deal with day in, day out. And vision, we translated that into two questions, which is integration between business and technology. The other one is the organizational culture. These are things that are also less visible, maybe, or people didn't quite appreciate the impact or the importance of these questions. And we'll address that more later as well. So people generally agree these are the hurdles, but they don't necessarily agree with us in terms of the sequence. So just to show that we actually talked about this a long time ago. What is a way to make things work? This is our report that we talk about this AI for the largest asset manager, for one of the top mutual fund in China, and Microsoft, how they got together. We thought this is actually just like BlackRock and Google working together. We thought this is a way to do things, right? That you need to understand how things are done. So this is our simple way of explaining this. We think the winning firm will be the ones that are stronger in AI and stronger in human intelligence. So this is the framework, right? AI plus HI is a winning formula. So not AI will beat HI or HI will beat AI, but a surviving firm or a winning firm, you need to be strong in both. And to capture that to the next step, because since we raised that issue, we've seen a lot of cases, and practically in all cases that failed, is because they didn't quite see this fin plus tech or AI plus HI as a philosophy, right? They kind of just did it independently, and that's bad, right? So we kind of crystallized this concept of a T-shaped teams, a concept we read in the first report, Investment Professionals Future, and we discuss it more at length in AI Pioneers. But then we essentially decided this was probably the way, the approach to solve all those hurdles, to overcome those hurdles. And then we actually did a separate report on this last year, the T-shaped teams report. We thought this is a way to address those issues. And what's the way to address it? Is we think there are just basically not enough talent in technology. So the T-shaped team is different from T-shaped skills in the sense that in the vertical bar and the horizontal bar, people are all specialists. The only people with T-shaped skills are mostly the ones in the middle that's connecting the two. The way we want to emphasize the difference is because people in investments don't understand technology, and people in technology don't necessarily understand investments. And that's the challenge we face. And that's a different challenge from all the challenges we've ever come across since the investment industry came into existence. We've never had such a challenge. So now to make this work, we need to find people that will be able to connect the both groups. We don't need a lot of them, but we need people who can connect us. So lastly, we wanted to say AI is not going to solve all problems. Just sort of a qualifier. You don't want to do AI and big data for the purpose of doing AI and big data. You wanted to do AI and big data because you've identified problems that are best solved using AI and big data. I'll also pause again, maybe for questions. If not, I'll just touch on the cases before I hand it over to David. I'll just explain what the cases are all about, and then you can maybe read for more details in the report. So these cases are all from the AI Pioneers report, so feel free to check that out. It's on the CFA Institute website. The report is we identify these cases using that matrix on the bottom. We basically look at the three areas, the three continents, based on that bar. On the left hand, the vertical bar, and the horizontal bar, the four areas. So we look for cases using this 3x4 matrix. And New York Life, we forgot to identify. This is a sort of asset allocation equities in the Americas, right? So they're a big firm. They're a multi-asset strategy, a product team. This is what they developed. So it's more asset allocation. So this is kind of their approach, right? They look at different factors, and in two of those factors, they added an element using AI and machine learning. So this is kind of, we wanted to highlight that it's the AI plus HI part. So you're not really forgetting everything you've learned. You're using AI to incrementally add value to the process. You're adding AI to different parts of the process. So the cycle, they use different, they look at 20 factors in under 4 groups. So 2 of these groups, a few of those factors, they're adding machine learning to analyze that. I guess that's a quick summary. So they said this is why machine learning was helpful, because it processes signals in a large number of indicators more reliably and faster, right? This is what Melvin mentioned in the beginning, is they're just get rid of a lot of the human judgments, get rid of our biases, and then they map and rank predictors of particular events by their importance. So that importance, that ranking is derived using machine learning. So this is also different, right? So not all relationships are linear, and this machine learning maybe is a better way of getting at this. And they mentioned some of the key takeaways is machine learning is really helpful. It helps us to make better predictions, and that this is how they value the different indicators is important. I'll just run through the other two cases quickly in the interest of time. The Schroders is a European case. They've developed this case using equities, right? So using a big data approach to help their equities team. So I think they started building this data science team very early on. And this is what we wanted to highlight, is because they've actually got this right. It's AI plus HI, because they had co-heads of this operation. And one is a portfolio manager and the other one is a data scientist. They together led the process, right? Led the different selecting of the projects, getting projects done, etc. So this is one thing that we found that was particularly helpful. So this is kind of the process to build the team. And the two key takeaways, a lot of them are reflected in the pyramid as well, is they thought having a senior sponsor is extremely important. This goes through the vision part of the pyramid. And to have the right mix of skills, this is sort of the, I guess, the talent part of this. So T-shaped teams actually speaks to the talent part. You need really three types of talent, right? And then this one is interesting. This is the largest asset manager in China, but even they couldn't afford to do this. Melvin and I were chatting about this a moment ago, about big firm potentially having a competitive advantage in doing AI and big data applications because they have the resources, right? The cost issue, they can leverage over a larger cost base. So a lot of the media science firms, and even the large ones like China Life Asset Management, they had to do this by relying on external vendors. So we talk about how they work with external vendors to develop a customized solution for them. So this is the question people always ask. I can buy off the shelf, but it doesn't give me an edge in artificial intelligence, right? We talk about AI plus HI. You want it to be having an edge in both areas. Buying off the shelf doesn't give you an edge in AI. So what are you going to do, right? So that's the challenge. So for them is they kind of took an off-the-shelf solution in a way, but customized it using their internal approach. So they had a lot of input into the process. So that kind of saved them time to market, saved cost, but also maintained the edge. So I think that case was interesting. So feel free to check out more of the cases in the AI Pioneers report. This is also an application in fixed income. And in the Chinese fixed income market, about 1/3 of the instruments are not rated. So that's just the way it is. And to be able to invest in this, they need to rate them. So they developed this internal rating system based on the factors identified by machine learning, etc., and managers' experience. And that's sort of what this project was all about. And this is sort of their key takeaways, is to do things quickly. So that's kind of all I have. And our conclusion is, if you check out the AI Pioneers report, we said AI and big data really is bringing about the most significant changes. And the successful firms, how do you respond? In the future, you'll want to act now. But investment professionals, how they respond, you need to understand and exploit the opportunities, right, by the technologies. But by and large, people asked us what to do from there. After they got convinced, we said you need to take two actions. And action one is embodied in this T-shaped team report, is you need to build this organization to adopt AI and big data. And action two is you need to develop applications that help you do this, right? And that's in the next report we're working on right now. So I think I want to answer the question that Oscar raised a moment ago. For me personally, what is a big challenge I have confronted in my career in data science? I don't have a career in data science, so that's unfortunate for me. And that's one thing I wanted to talk about, is that T-shaped team report is because we think for the investment professionals in the vertical function and the data science professionals in the sort of horizontal part of the organization, most of them, we think the best way to develop your career is to specialize. You know, I come from an investment background. If I work with an investment firm today, I think my best chance is probably to actually build on my investment skills, become a better investor. For data scientists working in that, their best chance is probably to work on their data science skills. We need a small group of people in the middle to connect them. Those are the people who need to understand both investment and data science. Those are very rare talents. Like I think David is one of those talents. David has a CFA charter, so he comes from a computer science background, but he also has a CFA. We see more of people similar to David's background than say someone coming from an investment background getting a computer science degree. And it is challenging because we estimated you probably need 750 hours study to get the CFA. And our guess to get to a fluent level of operating as a data scientist, you need about the same amount of time. So we estimated 15 undergrad to master level computer science and AI courses. So it probably takes longer than 750 hours, 750 to 900 hours to get up to that level, to finish these courses, but also, you know, the professional learning. You know, as you've got the skills, you need to continue to evolve. You need to stay updated, and not only as the CFA side, but also the computer science side. Things change very quickly there too. So it's challenging. So I think those are the decisions each one of you will have to make based on your personal decisions, based on your personal situation. What do you think is your best chance of surviving and excel in this business, right? Is it as a data scientist or as a investment professional or as someone in the middle? So that's all I have. I'll hand it over to David to introduce more of share more of his experience.
Thank you, Larry. Let me see if I can.
Let me stop sharing. Did I stop sharing already?
Doesn't look like. Let me try again, okay? Larry?
Yes.
I think I have some problem to share. Do you mind to share the 3 slides you have for stage 3?
Let me see. Let me find the slides.
Okay, so I don't, let me just get started, right? So my name is David Wang from State Street. If you don't know State Street is the largest custodian bank globally, and if I remember correctly, last year, not the latest number in terms of AUM, we're number 3 globally. We are mostly in passive index ETF products like Spider series, right? And we're also very active in the fixed market making, and some of other services. So Larry is helping me to share one of the use cases that was published in 2019. So I'm going to talk to this case a little bit more, and also share a recent case so you get a better understanding what's going on in industry.
Can you see the slides?
Yep. Thank you, Larry. So in this particular case, let me see. So in this particular case, right, we were asked to basically help our, trading business I work with a specific trading group to predict next day's trading volume because we are in index, passive ETF business, right? So we have a lot of these subscription, redemption, rebalancing, and investment decisions made time to time, and we have given our size every day. We have billions of dollars need to be, rebalanced, traded, executed, right? So these problems help to predict how many orders come in, right, for each market. So we can execute based on a view of algorithms we have to manage the total cost of analysis, right? So that's kind of the background. So we tried a few different things, right? First, we identify, by working with the traders, identify factors. So we use factors like index rebalancing, their schedules, vendors, and also the security rate change. Right? Sometimes you have dividend or the normal stock price fluctuation, right? Things like that. We also look into fund subscription redemption. We look into market events, macroeconomic factors, global economy factors, right, to help to predict our allocation size. Some of these things didn't work well, but some of these things work pretty well, like historical allocation, index rebalancing schedule, and some of these cyclical calendar-based, like quarter end, month end, and also market interdependency, there's correlation, temporal patterns between markets, right? And also some special treatment for some of the index providers. They have special business logic rules behind. The model works reasonably well. Back in 2019, for UX market, for example, we were able to predict with about 95% of accuracy level. Right? So that's reasonably well. So Larry, next page, please.
Okay.
Yeah, so just like Larry pointed out, right? It's a mix of it's a T-shaped team. So we have technologists from IT, usually specialize on high performance computing, and also we of course have AI scientists and the financial engineers involved. In the later stage, we involve model validation. So we have, all the model need to be validated scholarly. So we work with traders, right, on their problem and identify the factors and some of the specific factors they follow and the reasons behind that. So we can help with the right model and the right wire problem and the right features to solve the problem. So, any questions for this particular case? If not, I will move on to talk about briefly a recent case that we fully operationalized about 6 months ago. It's been doing pretty well. Okay, so I'm going to move on to the next use case. The next use case, what we do is basically help our own book of investments, all the factors they use, market factors they use for security evaluation and simulation of the factors, then drive value to risk and other things, right? So basically we do data quality control, like anomaly detection, right, for our like a fixed rate, volatility, OIS curve, eyeballs, cross currency swap, etc. Right? So to detect anomalies. Of course, when we did that, we have to do a lot of the, financial engineering, data analysis, usual stuff. It can be, multi-currency structure or cost and exchanges. Sometimes we involve high frequency data, right? Versus data snapshots. And also we look into cross asset type structure, right? See if there's certain pattern to hold, right? If there are any violations of that, that's outline. So I won't get into too detail of that, but we have been operationalized these models with business fully operationalized into all the investment processes. Use this set of market data. I looked recently. I checked last night, and basically, like for example, last 10 days, so we have most of the days the model were able to detect, few data quality issues across, the fixed IBOR and a few other category of market data. So it works really reasonably well. We reduce false alert dramatically. Before AI model was involved, the older process produce, statistics process with manual review, produce, a couple thousand of alerts every day, and people need to look into that manually along with vendors, etc., and managers. But now we reduce about 90+% of false alerts, so reasonably well. So I'm going to stop here. If you have any questions, I'm glad to answer. Inigo, back to you.
Thank you, David. Thank you, Larry, as well for your presentations. And I guess I had a couple of questions while we wait for more questions from the audience. But David, there was a previous question that Larry answered that I thought we also wanted to get your take on, and it's coming from Lautaro. Is there a change in tools used by portfolio managers in the last 2 or 3 years that you would like to speak?
Oh, yeah. So it all depends, right? It depends which company and which type of portfolio managers. I've seen some portfolio managers in top, active shops. They don't totally change the investment tools, but they supplement, right? Some of the AI products into gathering the information. Not to promote state sheet, but we have a product called price stats, right? So basically use alternative data, unstructured data to gauge inflation in different country, different markets. I know some of my contacts, portfolio managers, they use that. So it all depends. I think if you are looking to some of the larger, more conservative type of shop, maybe portfolio manager hasn't picked up on some of these things yet. So it depends. But the tools are there. Some of the portfolio managers, they definitely using them.
Thank you for that. And then just to follow up on the other question from Oscar, since you do have a career in data science and AI, what is the biggest challenge you have confronted or you're confronting in your career at this particular time?
Yeah, that's a good question. Right. So we're in business. So in business means you have to contribute to your top line or bottom line, right? Has impact on your business. So how AI can help that? So my biggest challenge is really looking from find the right problem to solve, and in combination of the right data set, because a lot of companies, including State Street, right, they don't have an AI data strategy. We have a lot of data, right? But the shape of data, quality of data is following mentality or philosophy 20 years ago. Even they're moving to cloud, whatever. But that's only from traditional technology perspective, getting better technology, but not for AI. AI requires high quality label data, for example, right? That way machine can really learn, what was wrong. Now, what is corrected? What's the value now, right? How was it corrected, right? So you need to have all these traces. So I call that a AI data strategy. And so, so combination of that, then you can commercialize some product or service or improve that service based on AI. So how successfully do that, I think it's my big challenge.
Let me turn it over to Larry. Larry, you spoke about the skills and the so what's necessary, the number of hours. You mentioned 750 hours of data science. So what courses should people be looking to take? How much programming, machine learning should they be learning? And what's your take on the transition to this type of career?
Well, we obviously ask a lot of people. So we mentioned this in the T-shaped teams report, and we can include the links to AI pioneers and T-shaped teams in the email we send out to folks afterwards. So there's a list of about 15 courses, right? Starting from the basics on computer programming to more specific AI and big data and machine learning courses. The courses obviously vary by school, depending on what schools you go to, the courses they offer. But it's about 2-to-1 computer programming to AI and machine learning. So it's not necessarily so specially AI and machine learning all the time. You don't need to take that many courses for that. But the core foundational programming courses are important. And I think our estimate is like, maybe that's like 1,000 hours to consume all the information, to digest all the information you get from the 15 courses. And because you don't only take 15 courses, right? To graduate, you take a whole lot of more courses. This is just within computer science and AI, etc. So to me, I think that's a big hurdle. But again, it depends on who you are. I think everybody has different skill sets and different learning aptitude. For me, I think investment comes more easily, and maybe not so much data science or programming. And so for other people, it could be different. So I think you really need to look at your own skills in terms of where you want to be, and then how you can, what's your best way, best chance of what gives you the best chance of success.
David, let me turn over to you as somebody who's working daily on with AI and data science. How do you feel that somebody should start their career? What steps do they need to take based on what Larry just said?
Depends on your background, right? If you are pure financial background, depends on, in front office or mid office, right, wherever you are. First, of course, if you're on that side, you need to learn some programming, like Python, some of the programming language basic stuff. And then you need to take some of these AI, data science, or data mining, some of the basic courses. So you understand the algorithm, mathematics behind the algorithm, pros and cons of each algorithm, right? So for what problem, what algorithm you want to try it out. But for you to try out, you need to have programming skill, right? And for programming skill, you also need to have a data inquiry skill, like querying your structured data or unstructured data, right? So some of these more kind of computer science background. If you are from the computer science background, you already have programming, language, right, knowledge. You have done that in the past for this traditional IT type of things. You still need to learn a lot of algorithm, AI concepts and courses in depth of some open source libraries. You need to really dig into paper code, right? So you really understand limitation assumptions of each algorithm. So you can explore different type of algorithm or mathematical, methods for your problem. In addition to that, usually, that's still not enough in our industry. You really need to be what you are doing in terms of investment, right? That's very, very important. even you are like a PhD, postdoc, professor level AI, that's not I have had some experience, right? That's not sufficient to solve our problem. You really need to be good, know exactly what you're doing, right? From, for example, portfolio management or portfolio construction, trading, whatever it is, right? You know the fundamentals in and out. You have framework. You have your own, techniques, financial techniques to make alpha or whatever, right? So then you can relay some of these computer science, AI background to solve your problem. So as I mentioned, right, and the big challenge for me personally, also let I mention like a T-shaped talent, it's all together means solve our industry problem. First, our industry, like investment management itself, is very difficult. A lot of uncertainty, a lot of styles. A lot of people, the work for some people use some maybe relatively small, narrow edge they have, right? Nothing AI, machine learning. So it's something very, difficult, plus another difficult type of technology. And if you combine that, if you want to generate a, exponential return on that investment, it's also difficult, right? So it's a lot of uncertainty. I won't say AI is just magic bullet, everything just works. It doesn't work, right? So you need to know your financial, your secret sauce or weapon very well, right? Then you talk to the expert on AI side to see what are certain problems that can help you within your own framework, right? You don't give up your stuff. I hope AI works magically for you. It doesn't work that way.
Thank you, David. My next question is for both of you. So you guys have talked about the current state of play of AI and data science, and I wanted to get your take on sort of what I was referencing of these reports coming out ever so frequently about the fact that AI and data science are going to dominate by mid-decade, so to speak, the investment process and potentially the investment decision making. So what is your take on that? How is it going to look 5 to 10 years out? Do you give credit to these reports that it's going to be so dominant? Let me start with you, Larry.
First, I want to echo what David just said, about the T-shape, talent, etc. I think we actually discussed a lot of that in our T-shaped teams report. The people in the middle, the innovation function, who understand both sides, is really critical in selecting the right projects, etc. So in terms of trajectory, that's also, I think, related to this, right? The reason we had to propose that T-shaped team structure, making a distinction between the investment professionals, specialists, and the technology or data science specialists, is because we don't have enough people in the middle, right? People like David is a rare asset today. So you don't have a lot of folks who understand both sides. And it's critically important for people to be in that middle to lead this product development, because you need to match the technology capability with the investment needs, because you're not doing the AI for AI. You need to understand what the investment managers need, but you also need the technical competence to know how to best deliver that from a technology perspective, right? So you can actually deliver the best technology that works. So the people in the middle is really important. So you'll want to be in the middle. We want everybody to have that skills. We're not there simply because our education system hasn't really provided that kind of training, right? There isn't a investment data science program or degree. I think with our report, hopefully more educational institutions will get into that. But we don't have that. But think out sort of 20 years, right? My advice to people of my generation who will retire maybe in the next, so many years, is that if you start picking up Python and try to do data science, that return may be low, because by the time you get there, it's probably too late. So, but you need to think out your horizon. If you have a longer horizon where you can actually make your investment pay, you should do that. If you're just starting out in your career, say 20 years, 30 years from now, you can imagine a larger percentage of people will be in the middle. The people who survive will probably need to know a lot more data science than today. But I'm happy that I don't have to do that, because it's not just my cup of tea. But for those people who want to survive in 20, 30 years, if you have that challenge, you almost be sure that you need to know a lot more. But to the people who are on the investment side, I'll also give you some advice so you can feel comfortable. We've mentioned this in a number of our reports, and we spoke to a lot of people that come from the data science side, right? Early pioneers, and they said they've tried this. They've dumped a lot of data into the algorithms and expect to get new information, and they didn't. So the models were spitting out the answer they already knew. So this goes back to our argument that the one that survive, the one that do well, will be following this AI plus HI approach. You cannot throw away your human intelligence. And that human intelligence mostly here is the investment knowledge. You don't want to throw that away, because that's valuable. People accumulate that knowledge over many, many years. We are doing the digging, not as efficient as machines, but we figure these things out ourselves. A lot of brain power, to figure out those things. So it's valuable knowledge, and machine won't catch up necessarily all that quickly. You want to feed that information, work with your colleagues, because your data science colleagues are there to help you, to actually make you a better investor. So I think you want to actually embrace AI, but not necessarily. I don't necessarily think AI will be better, on its own as well. So I think for the foreseeable future, it will still be AI plus HI, but AI will probably have an increasing share of that, equation. So.
Dave, what do you think?
Yeah, I agree with Larry. Right. So 5 to 10 years from now, I personally believe, it's going to be more digital, more intelligence, right? That I can feel myself. More digital means, there's going to be a lot of more data, high quality data, with maybe data, right for AI models, all that, right? Structured, unstructured. More intelligent means more and more companies, even including governing bodies, start to adopt in AI. I can tell that. I see that's what's happening. So it's going to be more of digital and intelligence 5 to 10 years now. Specifically to our asset management industry, probably back office, mid office, operational efficiency, client-facing stuff, even marketing stuff, right? Sales, those things can be with more certainty. The AI technique we have, like NLP, computer vision, Larry pointed out a few other things, machine learning, right? Those things actually technically, they already meet the threshold to solve these type of problems, right? So in the mid office, back office, I will see maybe a lot of more adoption with more certainty, right? But in the front office, investment decision, investment research, investment decision trading, market that side of our industry is a little bit different. I don't feel our AI science, data science, AI algorithm itself, right, evolved from basic data automation, data mining, to NLP, to computer vision, to deep learning. Today, we work with some professors in top universities, right? We exchange some of these ideas. They are working on something for next generation AI, right? So it's market based, because thousands of agents, intelligence agents make a decision, make a market, just like a financial market. So how AI need to fundamentally design different theory, different framework, right, to support that type of problem solving. So that type of AI technology is not fully there, still under developing. That's why you see, you can see, a bit adoption here there in the front office, but not a full scale, because I don't think that the AI science is there yet. Right? So I will see 5 to 10 years later that it's still HR, like Larry said, HR will be more than AI. AI probably play a supplemental role in data processing, some of the niche areas, but not a full scale.
Thank you, David. So you guys have heard our experts, and I think they agree that it's the combination of AI and HR that's going to continue to be relevant in the industry. So keep an eye on that. Let me turn to another question around some of the hurdles for AI and data science, and you guys sort of touched upon them, Larry, when you talked about the cost. So not everybody can afford to do AI and data science, and also there's some questions about privacy and management of data. Well, what is your take, Larry, about the hurdles for AI and data science?
Yeah. I think the cost issue is probably the easiest to resolve, and you see that comes down in the rankings over time. And although these people may not have the day-to-day knowledge of the cost implications, but costs by and large, I think as people pay more attention to this, cost is the easiest thing to overcome. The talent issue is front and center. You talk to people in the business, everybody is saying this, right? Because it's very hard to get well-trained data scientists with practical experience. There are not that many people that are well-trained to begin with. There are far fewer people with practical experience. So, you see the financial industry hiring from outside, from other industries, hiring data scientists with practical skills. So it doesn't matter where you work a lot of times, because a lot of things can be similar. It's people with real world experience is valuable. People with real world experience in your industry from your competitors can be extremely valuable. But what you can offer, they can probably offer too. So very hard to poach these people. I think by and large is, for now, the challenge is vision, and to me the most important thing is vision. So the senior management need to kickstart these projects, need to support the projects through the early stage adoption, intermediate stage adoption, and advanced stage of adoption. So we alluded to that a little bit in the presentation. More details in the T-shaped teams report. So we have a case each, a very elaborate case each for the 3 different stages to discuss the challenge they have in each stage. But to kickstart the process, you definitely need senior management support. To go through these stages, you also need senior management support. So we talked to a lot of folks, and one of them said, when asked, how do you prove you're adding value, every day to folks? They said, well, we didn't have to do that. Well, they didn't have to do that because they had senior management support, right? If you had someone who constantly questioned you, doubting you, they'll be asking for proof every day, and it's not always easy to deliver. So to the extent that those have succeeded, never thought about this, but you will increasingly need to think about it. You need to think of concrete measures to prove that your AI and big data projects are a success. So vision, you're fortunate if you work with someone with vision. What about if you work with a more average manager, who wants to do this but has doubts? So you need to be day in, day out, constantly spending your time proving yourself to them. And so you can imagine as this goes along, more and more of that type of thing would happen. So, my advice would always be to think of concrete ways. If you cannot think in terms of basis point, which portfolio managers like to think of, you can think in terms of how you improve the accuracy of your prediction, for example. Because, for example, the Tesla case, without this data information, what would you have gotten? You've got no data. You just a big guess, right? Based on other information. But now you have this, your accuracy has improved by so much. So, and then that can be translated into, the basis. We've written about this in a blog post, and this is one of the popular questions, is how to prove you've added value. And it's not always easy because it's not an end-to-end system yet, right? It's AI plus HI. So AI is only used in different steps and not always easy to measure how much that step added to the whole process. But I think you wanted to think of concrete ways to measure your success. So it's easier to prove to other people. It takes a lot of time. So people don't want to do that. I don't want to do that. But that's sort of increasingly going to be the demand, I think, for the industry, is you have to show us some money.
Thank you, Larry. What are your thoughts, David, on this particular issue?
Two things. I think you mentioned the privacy too. I'm going to talk about that a little bit and then follow up with what Larry said, which is essentially explain the model, right, to portfolio managers, to your users and regulators. So for privacy, this was increasing more important topic, right? Not only for regulators, also industry, also clients, right? It's extremely important for State Street, like a business, right? We have a lot of clients, big clients, data, everyday real-time data, right? Most of that. So we put together, we put together data governance framework, policy, everything, AI model, tap into proprietary review and by multiple parties, right? Data governance team, compliance, sometimes legal, sometimes need to get approval from client, before you can do it, right? So privacy, that's very important to us. Go back to Larry's point, how to explain the model. I personally went through, for adoption, how to explain the model is very important. I personally went through that cycle in Stage 3 the last 5 years or so. Basically, in the beginning, you have to approve your value, every model, everything you do, right? Not only prove the business value. Oh no, you need to explain all the model in and out, detail, every mathematical equation, everything you, right? So spend tons of time, basically prepare, because each technique you use for each problem is different, and you have to prepare weeks of time, basically how every step evolves, why these AI can theoretically, without any problem, to solve, that type of, business problem, right? It takes a lot of effort and not easy for people to understand, right? That's, of course, we have to, as the AI side of employee, we have to do, that's our job to explain. But on the other side, it's really education, A lot of people don't have education, right? And not to mention back office, mid office, but even front office, they're very much, with traditional school, finance, mathematics, financial engineering, and all that. They are very highly educated, smart people, but don't have much experience to AI science, data science type of approach. So you have to explain not only, like a sensitivity, attribution by factor, whatever else, and you also need to explain every technique you use. Explain a way they need to be convinced it works, right? And you show the actual results, and with attribution, and it works. And then they're still not comfortable.
Right.
Things like that. Still, we even compete against same data set, right? Same features. They use some of our features, but same features. We are 10% higher. That's that's a lot. There's probably 70% of R-square are like close to 80 plus. Right? Doesn't matter what they do. but the AI technique does help bring in additional, high order problem you can solve, right? And a fully approved, explained to many good people, but still cannot be productionized because there is too much stake impact on the investment process. They just don't feel comfortable. That's the only reason. So anyway, yeah. So adoption, I think, it just takes time. Not more people are educated. It's just like these audience, right? When I talked 5 years ago, it's kind of apple to orange. Now it's a lot of people on the other side of game. They started a lot of these online, took a lot of courses. It came up to speed to some degree. It's easier to work with now.
Thank you, David. So we're coming up to the top of the hour, and I think we have 2 more minutes for each of you to just give us any parting thoughts that you think our audience should leave with. So let me start with you, Larry, before I give it back to David and then Melvin.
I think we may want to just connect the last 2 questions you had, right? Is how long this adoption process will take, and then what are the hurdles? I think really is talent, right? We'll talk about this innovation function in the middle as that expand. I think 10 years from now, you'd see a lot of those people in management positions, and then that solves the management vision issue. It solves the product selection issue, and the surviving firms, the ones that are winning in this business, will need to have that capability, right? So you see a lot of those people in the middle of that T-shaped team succeed over the next 10 years. So yeah, I think if you want to survive like me, you don't want to necessarily need to study data science. If you want to do well and get into that middle and get into management positions at investment firms, I think that's important to understand at least half as much as a data scientist. And you want to have that balance so you have credibility with them, so you understand what's going on, and then you can lead the firm and the teams to success. So I think we'll see a lot more of that happening in the next 10 years.
Thank you, Larry. David?
Yeah, so I just feel, the world is becoming more digital. It's going to have more data, right? It's going to be a lot of data-driven type of decision-making, investment process, etc. So I will say, just if you haven't started, I think AI is a big part of course, using the data, right? So if you haven't started, I think it's time to really at least understand some of the concepts, some of the, applications, context to it. So be prepared for next 5 years.
Thank you both. Thank you for your time, for participating, all your insights, which are extremely valuable, and I think our audience will have appreciated them. And Melvin, I'm going to pass it on to you, and thank you for being here. Melvin.
Thank you very much, Inigo, Larry, and David. I think this is a really big challenge for every professional in the industry. In some way, I don't know, 1% or 100%, everybody engaged on this audience finally needs to learn about data science and artificial intelligence, and maybe not as a programmer, but for sure as a user. Right now, everything is evolving as fast as is possible, our imagination could reach. So I really don't see where we are going, but we need to be prepared. The blockchain revolution, we had our previous webinar on that, is also amazing. Web3, metaverse, and now with artificial intelligence, something big is coming. So let's be prepared. CFA Institute is committed with giving our members the latest topics that could be impacting in our world. Surely this is one of the biggest and most important one across the industries. It doesn't matter if you are a trader or if you are a risk analyst, this is changing our ground, our space of work. No? Thank you very much again for your thoughts, your comments and recommendations. Finally, to our audience, also again, it's a pleasure to be with you. And I invited you to our next webinar. In this case, will be about women in finance, another very challenging topic everywhere in the world, but we are strong supporters of women in our countries to reach the highest potential that they could have in this industry. Thank you very much again, and see you soon. Bye-bye.